integral, let's just say it's 4 dx. Do you remember graphically what that looked like? Let's say I go from 0 to 3. Do you remember what that meant here?
There's a vertical asymptotes at 0 and 3.
Yes, they're not necessarily. They're more called like they're called the boundaries of the integral.
Okay.
So the y equals 4 goes like this, but we only care about it from 0 to 3. So you mark those down here. You can show this shaded in if you wanted to, and you're finding this area. So all you know to do right now is to use geometric formulas. So the area of this is, and I think your instructor is trying to show you this, it's 3 minus 0, because that's the width.
Yeah, times
and
4.
Then 4, which is the height. But he's trying, or she's trying, I think it's he, he's trying to show you like where the numbers come from. So it's b minus a, 3 and 0 here to get 12. Okay.
Right.
Is that all right?
Yeah.
Okay. So real quick here, let's say I wanted the integral from 2 to 5 of 1/2 x. I'm sorry, 1/2 dx. Do you feel like you could do something like that on your own?
Yeah, so you do box and one half, and then so 1, 2, 3, 3 times 1/2. So 1.5.
Yes. So yeah, so it's the height is 1/2, 5 minus 2 is the width, times 1/2 here gets you to 3 halves.
Yeah.
Is that what I heard? Okay, great. Now there's a bunch of properties that are given on this slide. I guess it's slide 3. I'd like to cover those in the context of kind of an example that's given here. Some of them you probably already know. Okay, so, all right, so let's say this is given. I'll have to copy this in each time, but let's say I wanted the first thing is, what if I wanted the integral from 1 to -1 of f of x dx? Okay, and the answer to this, it's that first property that's given on that third slide. Let me snip that in here. And what this says, it says that if you just switch the bounds, but you keep everything else the same, it's negative of whatever that number is there. Do you see how from this one up here to this one down here, the only thing I did was switch the order of the bounds?
Oh yeah. Okay.
So that makes it
-5.
Yes. Okay. So similarly, and we'll just tuck that right there. If I wanted the integral from 4 to 1 f of x dx, what say you? Based on this number here, all I did was flip the bounds.
2.
Be 2. So that's property number 1 on there. So I'll go through them, I think, one at a time here, if that probably makes the most sense.
Yeah.
Okay, so let me grab this, come down here. All right, so the next property is, now I'm going to say, what's the integral from -1 to -1 f of x e to the x dx? Now, first thing is you should be like, I have never seen that, Matthew. I don't know how to do that. That's a distracting thing. Your instructor, property number 2, and this is what you're looking for when you're doing a problem like this, is if the bounds are the same, and that's why I don't like the way these are written. Maybe you got some more information in class, but if the bounds are the same,
Yeah, I remember this.
it's always zero. It's kind of like if something's to the zero power, it's always one. Doesn't matter what's inside. So whenever you see something like there's no way I've ever seen that before. I can't do it. It's possible that it's because it's a very simplified version of it.
Okay.
All right, is that enough for that one?
Yeah.
Okay, great. So let's grab this again. All right, so the next property here. Okay, so let's say I'll choose this middle one here because let's say I want the integral from 1 to 4, 3 f of x dx. Okay, so the third property, what it says in words is that, and I'm gonna snip it in here, is that you are allowed to bring the constant, you're allowed to actually bring this constant out. Okay. There's actually a couple of ways I actually like doing this. So let me show you the first way. The first way is you literally like move that 3 outside. So it's 3 integral 1 to 4 f of x dx. That's way number 1. Another way, I'm going to rewrite this. You can decide which way you like, is you can actually literally just move this integral here. You can just right there, and then you can just, get rid of that. I mean, it's the same thing, but like, it's up to you if you really want to rewrite it every time.
Okay.
But in summary, what it does is it says, we'll take whatever your answer was for f of x dx, which is -2, and you multiply it by 3.
Okay.
Let's do 3 more examples from this. So you just take whatever that number is, and you multiply your final answer by it. Okay, so let's say I want the integral from -1 to 1 for f of x dx.
So you take the 4 out.
You take the 4 out, okay, and you write 4 integral -1 to 1 f of x dx. And what is this part equal to without the 4?
5.
5, so it's 4 times 5.
So 20. Oh, okay.
Now let's look at this next one here. Now I didn't say this yet, but the bounds have to be exactly the same for this to work. Like if I don't give you 1 to 4, you're like, I can't do it. Just can't do it. Okay. So let's say I put -1/2 f of x dx here. Again,
so
you can bring this out.
-1/2 times -2.
Yes.
So
just 1.
Yeah.
Okay, so I can go integral -1 to 1. I can go 100 h of x dx.
700.
700. Okay. So you're like, oh,
You
I
don't
got
even
it.
need to rewrite it.
Right. So you're like, oh, I got it. Now let me give you a synthesis of a couple of these to see if it's clear.
Okay.
Okay, and then we'll add in some harder stuff because there's a lot here. This is actually what I think you'll get a quiz on. You'll get some given stuff. And then,
and the quiz is all free response. I forgot to mention that. It's like 6 questions or something.
Oh, wow. That sounds pretty intense for a quiz.
I know.
Okay. What is from 1 to -1, -5 f of x dx? So there's 2 things going on here. I flip the bounds.
So you have to go -5 times -5, right?
Yes.
So
yes. So when you flip there's a lot of ways to it, but yeah, the answer is 25. But
yeah, so you change the sign of that 5 up there.
Let me show you what I think your instructor would be looking for. If you flip the bounds, because you want the bounds to match what you have, you then put a negative there.
Okay.
And that's that first property I showed you right here. Like your instructor wants to see that. We agreed you said it's free response, so we want to, that's like showing your work. And then you still have this -5 f of x dx. So now you can bring that negative out, or -5 out, and it becomes 5 integral -1 to 1 f of x dx. So your instructor wants to see that you get it back to something that's given.
Okay. I see.
So then you'd say, oh, it's 5 times 5, Mr. Instructor, it's 25.
Okay.
Okay, a little more synthesis. All right, so we're going to focus on this middle one. Let's say I want the integral from actually I need to bring in one more property here. That fourth property, do you think you understand that already or not on that page? The 1, 2, 3, fourth one down on the third slide. Do you think you
hold on, I need to pull it up.
I'll just snip it in here. Do you feel like you've got a good grasp on this one or not? Like, it looks confusing, but I'll give you an example of it.
I don't really remember what that one was.
Okay, well, let's look at it then in this context. So let's say I give you the following. I want the integral from -1 to 1 f of x plus h of x dx. So that property, what it says is that you can separate these integrals. So it's the integral from -1 to 1 f of x dx plus the integral -1 to 1 h of x dx. So it's almost like you're distributing this dx to both. Okay. Notice they have the same bounds. Okay, that's very important. They have the same bounds. All right. But you're just splitting them apart. Because okay. you know this first value. What is this first value?
5.
5. What is the second value?
7.
7.
So just adding those. Okay.
Yes. Okay. So sometimes though, it's not that like explicit, like that's kind of the like nicest example that you would see of this. Okay. But notice the bounds have to match too. Okay. And the instructors are very picky about notation. That's what I was trying to tell you, is like, if you don't write DX, you're going to get marked off. You don't write DX. That's, I think, why it's free response, because your instructor really wants to emphasize notation right now. So every time you have an integral, it's paired with this DX. The integral is paired with this DX.
Okay.
All right. So let me go to the one that I wanted to do. Let me snip this down. All right, so let's say I want the integral from 1 to 4 f of x plus 5 dx. Okay, so you're going to use that property from the previous problem. You're going to split this apart. Okay, it's going to become the integral from 1 to 4 f of x dx, because you're kind of distributing that in, plus the integral from 1 to 4 5 dx.
Okay, so -2.
Okay, good. And then this one is like what we did, very first type of question to start.
That one's just 1 to 4 -2. -2 times 5, right?
It's plus. No. So this one
but
right
like
here,
you do like 5 times -2.
No, this has nothing. This has nothing to do with f of x. Now, remember, this is a graph of y equals 5,
okay, so
right, from 1 to 4.
Oh, so 5 times 3.
Yes.
Yeah,
5 times 3.
3, so 15, so 13.
Yes. And that's your quiz question you're going to see. So let's try another one. There's a lot of these we can do, but do you feel like that was clear?
Yeah.
Okay, so try and give you one like that here next. Maybe I need to make this a little smaller. Okay. Let's go integral -1 to 1, 2 plus h of x dx. Can you try this one on your own, please?
Yeah. So So do you just bring this the 7 from the h of x one?
Let me write it out step by step in case you want to look back at this later on. So it's integral -1 to 1 h of x dx.
Oh, okay. So it's not okay. Wait,
So this is 7.
right, and then you got to do the
Yes, this is a rectangle over here.
that one, do a little graph. So -1 and 1, 2, 2. So 4 plus 7, which is 11.
Yes. Yeah, so that's it's 1 minus -1 times 2 if you need to do that. 4 plus 7, which is 11.
Yeah. Okay.
Give me just 30 seconds here. Get I think I have to sneeze. Okay. Okay, let's do another one here on this. Just increase the difficulty slightly. So what I can also do is I can add in like coefficients. So I can say things like, what is the integral from -1 to 1 for f of x, excuse me, plus 3h of x dx.
All right. So take integral from -1 to 1 for -1 to 1, 3 x. I take 4 out. 3 out. Um, 2, 5.
So do you have a line that looks like this second line that I just wrote down?
Yes.
Good, because
I'm just making the little box right now.
there's no box for this one because you're given these, right? Like f of x from -1 to 1 is 5.
Oh, so you don't need to do, oh, so it's just 20 plus 21. So
Yes.
41.
Yes.
Okay.
Okay. Now let's do one here. So I'm gonna again just a couple of modifications.
When is the like the situation when you would need to make the box?
You need the box when you're and it's not necessarily just a box. Whenever it's more than
yeah, like a shape.
so notice it's a sorry. Here, see, that's just a number by itself.
Uh-huh.
2 dx.
Oh,
It's
so no
a
like
number
f of x or no h of x.
or no x.
Okay.
Because I do think you'll get, I won't want to ramp up to that, but I do think there's this like question you'll see based on it. So let's just do one more of these. Let's say I want the integral from 1 to -1 minus 4 h of x minus 2 f of x dx. So again, notice I flipped the bounds here. So however you want to tackle this problem, you will have to incorporate flipping the bounds in that. And you can either do it right away or you can do it, later on.
Okay. So just do -1 to 1. Minus Can you write down the next line to make sure that I did it right?
Sure. Did you flip the bounds yet, or are you waiting to do
Yeah,
that?
I did.
Okay, so if you flip the bounds -1 to 1, you put a negative out in front.
Yes.
And then it's kind of like algebra. You can actually distribute that.
So
you got to distribute to both.
Okay. So that becomes negative still.
Well, it becomes 4 h of x plus 2 f of x dx.
Oh, okay. So now once you get to that point, you don't need to keep that negative on the outside.
No, because you've assigned it. It's like the distributive property. I mean, that's
Okay.
essentially what it is. It's called I mean, there's distributive property of integrals, but nobody. I mean, you're kind of past that in math.
Okay.
Because if you wrote them separately, like there's a big parentheses on the outside here, I guess, would be one way of looking at it.
So then you just, can I see the numbers again?
Yes. So h of x is 7 and f of x
So
is
just 4 times 7 plus 2 times, I forgot the
2, I think.
2.
Or 5. I think it was 5. Doesn't really matter.
8 plus, was it 2?
It's 5.
It's 5 though.
Yeah, so it's 28 plus 10.
38.
38. Okay, so you will get questions that will ask you to utilize one or more than one of these properties. So let's do a couple more. That's okay with you?
Yeah.
Feel like you're getting a lot of good practice on this. So the next kind of type of questions it's one you alluded to there. So real quick again, let's say it's 1 to 4, 3 f of x minus 5 dx. Okay, so this becomes the integral from 1 to 4, 3 f of x dx, okay, minus 5, or integral 5 dx. Let's do it that way. 1 to 4. Is that okay, or is that clear or not?
You just took 3. Yeah.
3 goes on the outside. You separate them. You got to write dx for both. Now the one on the left is 3 times -2, because that's f of x. F of x is -2. How do you do this one on the right when it's just a number?
Just multiply them.
It's 4 minus 1 times 5.
Yeah.
Okay. So
that's that box thing.
Right. So you're asking about that, and it's 15. It's -6 minus 15. It's minus 21. So it could be negative. Okay. Now, like, let me give you because I want to introduce something new here. Let's say the integral from 1 to 3 f of x dx equals 2. And I want you to find the integral from 1 to 3 f of x plus x dx. So this is totally new. Okay, but you know to separate these. You know to write 1 to 3 f of x dx plus integral 1 to 3 x dx.
Yeah.
So this right here is 2. Okay, yay, well, that's 2. This on the right, you have no idea how to do, but we spent a lot of time yesterday graphing. So if you can graph it, you can figure out this answer. So y equals x. Sorry, go ahead.
Oh, and then you do the bounds, right? Yep.
Yep, and you find the area in here.
So it's 1/2 times 2 times 1, 2, 3. So
This whole thing is 3. Yeah.
Yeah. So then
Now,
5.
Now let's say I put yeah, so let's for 5. Yes. Okay. So what you have to be comfortable with is the like them giving you this, them flipping the bounds, flipping the bounds, putting a number in front, flipping the bounds and number in front, adding functions, adding these, adding a function with a number, and maybe a function with a variable. And those are like the possibilities that you could see. So would you like another one, or do you want us to move on to something else?
Let's do one more maybe.
Okay, make one up here. So let's say I wanted the integral from 0 to 5 h of x dx equals 3. And I want the integral from 0 to 5 h of x plus 2 dx. You know, try this one on your own, please. And
dx plus that's 3. So that's 1/2 times.
I'm going to write out a few things, but only you can only look if you feel like you need the assistance on this.
I got 25.5, but I feel like that's not right.
Okay, so we got the first one's 3. Is that right?
Yeah.
So that's 3. The next one here, the graph here, is pretty straightforward. It's just a triangle again, and it's got a base of 5 and a height of 5. So it's 1/2 5 times 5. Okay, which
Yes, I
is
got 12.5.
12.5. And then this one is 5 minus 0 times 2. So that's 10. So you're
Oh, I
completely
was
correct.
right.
Yeah. So do you recall that there was one other function that we did from yesterday, the circle one.
The semicircle, yeah.
Yeah, so that could be incorporated here. Like they could tell you the integral from 0 to 3, h of x dx equals 1, and they could ask you the integral from 0 to 3, h of x dx, I'm sorry, h of x plus the square root of 9 minus x squared. Now, I don't expect you'll get this, but your instructor, kind of preface that like you would need to know that this is that quarter circle there.
Right.
That's what that one is. So the answer here is it's 1 plus pi 3 squared over 4.
How do you know it's a quarter circle, not a semicircle?
Because it's not negative here.
Oh.
Yeah, it's not -3. If it was -3 to 3, that gets to the other side.
Got it. Okay.
I'm probably throwing too much at you. I wish I knew. Like, I wish I knew all these possible topics because then we could cover them all.
No, we did do a semicircle one in class today, so I think that's good.
Right. Let's say there was a 5 in front. Do you see that would just come down here?
Just multiply, yeah.
Yeah. Like there's little things that can be done that can make these appear like there's no way you can do it. And I know we're going to move on, but let's just say it's 2 to 2 f of x plus x squared plus square root of 4 minus x squared dx. What does this equal?
0.
Yes. Okay, let me go back to the PowerPoint and see what else you've got. Oh, there's this mean value theorem. Was that emphasized much in class?
That's the one.
I'm sorry, average, I guess mean
yeah,
value.
the average one.
Was that emphasized much?
Yeah.
Okay, so let's do this. You got your calculator handy?
No, but I can get it right now.
Okay, please do.
It's gonna be no calculator.
Oh, never mind. I was gonna try and do some mean value ones, but
oh, so you need the calculator? Just you can only do it with the calculator?
No, I just let me try to I was going to use the calculator to have us do some more integrals, but we'll just briefly talk about what this is. It's the same thing you just did, except there's this extra piece right here. So like we just covered everything on the right. And then on the left is this extra piece. And we'll do some examples, but let's say the integral from 1 to 3 f of x dx equals 10. And the instructor says, I want the average value of f of x from 1 to 3. So we're using this formula here, and this is A and this is B.
Okay.
So the way we do that is it's 1 minus b, 1 over b minus a integral a to b f of x dx. But you already have this. It's 1 over 3 minus 1 integral 1 to 3 f of x dx. But see how you have this is given. That's 10. So it's the same thing we did before. You take the integral, but then you have to multiply it by this number in front.
So
this 1 over b minus a is the only thing that's different about the average value. It's an additional piece.
Okay, so then you just multiply by 10.
Well, it's 1/2 times 10.
Right.
Which is 5. Okay, so let's try one. Let's do another one here that I think will be maybe clearer. What is the average value of f of x equals x from 1 to 5?
Okay.
So I'll try to set this up for you here. So the average value is 1 over 5 minus 1 integral 1 to 5 x dx.
So you have to set up the integral yourself?
Yes.
Oh,
But you can see how the numbers map, right? Like that's a, that's b, b minus a.
yeah. Yeah.
Okay, so that gives us 1/4 integral from 1 to 5 x dx. So this part right here, you do from, since you don't know any formulas for that, you have to graph it and say, oh yeah, it's the triangle thing. It's this. We got to find this area.
Okay.
The basis for, I'm sorry.
5, yeah, 20. Oh, no, half of 20, so 10.
1/2 4 times 5. Yeah, and equals 10 over 4, which is whatever it is, 2.5.
Okay.
So just really quickly, because you will see this, if you put a line at 2.5, it's the like, is that right? 1 2 3 4 5. Did I? Okay.
You graphed
This is right. Okay. Yeah. There is some physical meaning, but let's not get into that right now. Let's do another one here of these. Let's do the average value of f of x equals square root 9 minus x squared from -3 to 3.
So
See if you can set up that integral before I write it down here.
it's b minus a?
Yes, b minus a.
3 minus 3. Okay, I think I set it up.
Okay, so it's 1 over 3 minus -3. Okay, this is always a positive number, by the way. So it always gives you a, like the average value has to be a positive number in most cases.
Okay.
So that's -3 to 3 square root 9 minus x squared dx.
Yeah.
Okay, so it's 1/6.
Wait, so for integrals, the first number always goes on the bottom, right?
Yes, yes,
Okay.
it's bottom to top that way.
Okay.
So then this right here is a circle of radius 3, but it's only,
So this is the one that is a semi.
that's right, it's a semicircle.
Okay, so then it's pi times 3 squared over 2. So then 9 pi over 2 times 1/6. Yeah.
So see how these can get like sort of like, but you can just, he can build in things that you've already learned about it, but the average value just adds this part in front.
Yeah. Okay.
So let's go back to those 3 integrals real quick. Let's just get the average value of each of these. You'll be able to verbally tell me, but let's just get the, so the average value of this first one is 1 over 1 minus a -1 integral -1 to 1 f of x dx. Like that could be a problem. And then it's just 1/2 of 5/2.
Yeah, okay.
But now let me just slightly increase the difficulty here. And we're not going to use that one. We're not going to use that one. So it'll say, what is the average value of, and it'll say like, let me write this way. F of x plus 6 from 1 to 4.
So you do 1/4 minus 1, 4. One over 3. So then do you do -2 plus 6 in that box?
Say that one more time.
Do you do -2 plus 6?
Well, you have to break this apart, right? It's integral 1 to 4 f of x dx plus integral 1 to 4
Okay.
6 dx.
So in that part, the middle part is -2.
Yeah, so that first part's -2.
Yeah, and then that one you need to do the box.
Yes.
Oh, well, so it's just 1, 2, 3, 4, 5, 6.
And this 1/3 goes on the outside of everything. So you might want to wait till the end to do it.
Yeah, okay, so then 3 times 6, which is 18, plus -2, so 16 times 1/3, which is, yeah. Okay. The other thing that I had a question on was the last two, the 14 and 15.
The more examples.
Yeah, and the example slide before that. Just
Yeah.
I forgot why we did the line, what that means.
So let me snip in a couple of these and try to try to keep some clarity on this. I feel like this is a little too soon for you to be beginning this, but like, do you, so this is what's given on the left. Do you remember that if you take the derivative, it becomes, that's what the instructors, that's where this is coming from. Like, you're supposed to know, like, how do I get 2x?
Derivative things.
Well, that's essentially what you're doing, and that's the rest of this, that's the rest of this class.
It's so confusing. Like, I get it, but I don't know how to go backwards.
Right. Well, yeah. So let's just start this from the beginning. Let's say it's integral 0 to 5 2x dx. Here's the thought process. You somehow come up with x squared, which is very difficult. Like, it's always harder to go backwards than it is forwards, which is what you're doing here. You're trying to well, what do I take the derivative to get that? There's eventually a rule you'll learn which will help, but you're not given that yet. You draw this line right here. Do you remember that from class?
Yeah.
And then 0 comes down here because the lower bound, 5 goes there because it's the upper bound.
And then you just plug those into the x, right?
Well, you do top minus bottom. So it becomes 5 squared minus 0 squared.
So 25.
Yes.
Okay.
Okay, so now let's do another one here. I'll make them slightly different. Let's go integral. 1/2. No, that's probably beyond what you're trying to do. All right, so let's just do the e to the x dx from 0 to natural log of 4.
Oh.
You're supposed to remember that e to the x is itself, like the derivative of e to the x is e to the x.
Okay, and then
And
you
that-
line, and then it's 0 and ln 4.
That's top minus bottom.
So
So it's
then it's
e to the natural log of
e
4.
ln 4 minus e to the 0, and e to ln is 1, right? And so then it's just 4 minus 1 equals 3. Yeah.
Yes. Okay, so here's how, let's just do one more little synthesis here. Let's say it's from 0 to 1, e to the x plus 2x dx.
So you do e to the x 0 to 1. And that's, so you did two of them. Okay, yeah.
Yeah, you
And
break them
plus
apart.
x squared 0 to 1. So then it's e to the 1 minus e to the 0. Well, what's e to the 1?
Just e.
Oh, e minus 1 plus 1, 0. Yeah. Cool.
All right, do you feel like you got your math workout in for the day?
Yeah, definitely.
All right, I know there's a lot here. You know, if there's a short question, I'd be happy to answer for you between now and your quiz. You know, just text it over, or if
Okay,
you want to do something on social media, that also helps me do stuff on there. So
perfect.
thanks so much, and
Thank you.
I'll see you next time.
Thanks.
Bye now.